Welcome students. Today we will discuss about simulated annealing technique. Okay, you can put the heading simulated annealing technique. Simulated annealing . So, if you in the previous class we have discussed about hill climbing algorithm. So, the main drawback in simulated annealing, the main drawback in hill climbing technique is it may trap in local minima or maxima. Local minima or maxima. That is the main problem. So, in order to avoid that, we are going for simulated annealing technique. How we can avoid local minima maximum is, here we are introducing one parameter T, that is a temperature. Based on the values of that temperature T, you will perform either global search or local search. Okay, global search or neighborhood search. Okay, so let us see the name. Actually, you can see what is this simulated annealing. It is a variation. Okay, it is a variation of the hill climbing technique only. Hill climbing, it is a variation of hill climbing technique. So, you can see actually this technique is inspired from the metallurgy, okay, phenomena of metallurgy, annealing phenomenon of metallurgy. That means in metallurgy what we will do means, to get desired shape of the objects, we will first heat and then we will perform the cooling. While performing the cooling process, we will simultaneously change the shape of that object. While molding the shape of the object, we will decrease the temperature. By doing so, you can achieve the required shape. So, here also in our simulated annealing technique, we will introduce a parameter called T. This T, what we call as a temperature parameter. So, if the temperature T is high, what will happen means, we will perform global search. As the T is reducing, as the T is large, if the T is little bit small, we will perform neighborhood search. So, depending upon the values of T, okay, we will perform two different types of searches. So, in fact, we can tell you in another way also, in other way also. Depending upon the T, that means if T is large, what we will do means, the probability of accepting inferior solutions is large, is more. If T is small, the probability of accepting inferior solutions is less. So what is the meaning means? So the logic is very simple thing. Say for example, if it is a maximization problem, if you are having two solutions x2 and x1, for x2 the evaluated value is x of 2 and the evaluated value of x1 is like this. Say for example, if f of x is greater than x of 1, in maximization we should accept x2 as a best solution. We should accept this x2 as a best solution, okay, in hill climbing. But in simulated annealing, what we will do means, even though f of x2 is greater than f of x1, what we will do means, this is in hill climbing. We will take x2 as a best solution, whereas in simulated annealing, SA, the probability of accepting x1 is more. The probability of x1 as best solution is more. That means instead of ignoring the x1 solution entirely, we will consider it as a best solution. Best solution is less. This when we will do means if t is large. If t is small means these two will be vice versa. That means the probability of x1 is best solution is less and probability of x2 is best solution is more, okay. So depending upon the t values, by doing this we may arrive at global maxima or minima. So that is a main thing what we have to understood. So in short, we need to understand this. Annealing is the process in which materials are raised to high energy levels for melting, and then they are cooled systematically to get the desired shape, okay. So with this basic understanding, we will write the algorithm, okay. We will write the algorithm. In fact, we will write the algorithm. We will write one by one, step by step algorithm. So first I will write a simplified version of the algorithm, in simple notation, simple simulated annealing SA algorithm. The first step is I am writing down the important steps. Initialize the parameters. And then that means what you have to do means you have to initialize the solution capital S, some random solution. You can apply some random function to get S, okay. So not only that, you have to initialize the T parameter also. So initial temperature, okay, this will be high, okay. And also you need to set the maximum number of iterations, max iterations, how many iterations you need to perform, how many number of iterations, okay. This you need to understand, okay. For each temperature you will perform maximum number of iterations, that is the meaning. So now let us write the loop while the T temperature is less than T naught. Let us suppose this is the final, or you can write final. This is the initial temperature. Slowly we will decrease. In the third step, again you check while, again you can put another loop also. N is less than or equal to maximum number of iterations. Maximum number of iterations. So within the fourth loop, fourth step, so solution S dash, you generate a solution with the help of some change function. For this change function, you give S and some control parameters C. So if you give S and C, so control parameters means here the control parameter C is, this also you have to initialize. So I will write in different color. C means it is a control list. C may contains a distribution function, random distribution function, or you can take for simplicity, let us say Gaussian function or norm, which is having mean 0 and standard deviation 1. So you will get S dash, that is a new solution with the help of change function. Now you compare if f of if the objective function f of S dash. So let us suppose we are doing this simulated annealing for minimization. Let us suppose minimization. If f of S dash is less than f of S, that means S dash is a better value. Okay, so S dash is a better value. So what we will do is we will simply replace S with S dash. That means you will substitute S dash into S. Say for example, if this condition is false, that means if else f of S, here we are writing the algorithm for minimization, simulated annealing algorithm for minimization. If f of S dash is greater than f of S, we will not simply what you call delete it. We will not ignore the S dash. What we will do means we will compute the metropolis, we will apply the metropolis function. So we will see what is the metropolis function. We will compute the difference delta is equal to f of S dash minus f of S. This is the 8th step. And the 9th step is you compute, you take some random value with the help of some random function, some distribution function. Okay, R value, let us sample a R value from the random distribution function. Now you compare if this R value is less than this formula, exponential of to the power of minus delta by k into t if R is less than this value, then what we will do means we will replace S with S dash. So that means you will substitute S dash into S. Okay. If R, that is a sampled value, random value, if it is greater than this exponential, you will not replace. Okay. So there you can close the while loop. Okay. Here you can put the end if loop, end if. So this is the connection between this one, and then we write the 13th step, another end if, so this is the block corresponding to end if. Now finally we have to close the end while. So you can see after reaching the end while, what we will do, 1 minute. End while, and after that the 15th step, you decrease the temperature, because at each iteration you have to decrease. So you take some fraction, okay, you take some fraction A into T, you multiply it, and then finally in the 16th step you can close the end while. Okay, and then finally you can return the best solution. So return, here the best solution is stored in S, so you can return. So in this way you can write this algorithm. I think it is understandable. This corresponds to this one, this corresponds to this one. So now you will understand how the process is going on. So you need to understand this process. So this one is metropolis function, metropolis, or you can say as a metropolis rule. So what is metropolis rule? So whatever we have applied this process, we have applied the process now, this process. This process is what we call as a metropolis rule. So that means this is the minimization problem. If f of s dash is greater than f of s, we will not simply ignore s dash. So we compute metropolis rule as per the metropolis rule. We will accept s dash. So periodically for each temperature we will run n number of iterations, and then we will decrease the temperature. At the end of, you will get the S as a best solution. So this is how the algorithm works. So a more detailed algorithm you can refer textbooks. So it's a simplified version of the simulated annealing algorithm. So here you can use in change function you can use some random function to get new value, and then this formula what we call as this is a metropolis rule. Okay. Thank you, students. You can note it down.